Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and it's a lot of really smart people there. Today's puzzle is called Enter Maturity by Not Very Neat. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have sum dots, where digits in cells touching a gold sum dot must sum to the indicated total. And digits may repeat if allowed by other rules. So that means these 4 digits must sum to 16 because they all touch this sum dot here. These 4 cells must add up to 15, these 4 must add up to 17, these must add up to 18, etc., etc. And we have entropic lines, where any set of 3 consecutive digits, I should say, along the peach line must contain one small digit, which is 1, 2, or 3, one medium digit, which is 4, 5, or 6, and one large digit, which is 7, 8, or 9 on those 3 digits. So you could have something like, for these 3 digits, you could have something like 7, 5, and 1. And this would be valid for these 3 digits on the line. And then this could have something like 8 here. And this would work for these 3 digits on this entropic line because you have one digit that's low, 1, one digit that's medium, 5, and one digit that's high, which in these 3 cells would be 8, and in these 3 cells would be 7. So that's an example of how entropic lines work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, well, these look like prime for basically just coloring randomly, and they have to be 3 distinctly different digits. So, I guess we'll make this pink. We'll make this orange and this yellow. So then this must be 2 away here is orange. 2 away here is yellow. So every third digit then must be pink. So we have pink, 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 pink. So those are all pink. These are yellow, so every third here is yellow, and that's pink also, huh? So we have yellow, 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 to yellow, yellow, yellow. And then, wait, hold up. That's not right. This is yellow and this is yellow. So we have yellow, yellow, yellow. Then these must be orange. And if I did that correctly, it should be pink, yellow, orange, 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 pink. And that did. Okay, so that works. Okay. Huh. We have 2 yellows here. And we don't know what the rest are. We have orange and pink here. 2 oranges here. Can you ever have 2 oranges here if these are different sets? Okay, we know in... Let's color the ones that we have 3 of in each row and column as the other ones. So row 2, we have 3 pinks. That makes this yellow and orange in the rest of row 2. Row 3, we have 3 yellows, so that makes the rest orange and pink. In row 4, we have 3 oranges, so that makes the rest yellow and pink. Okay, this is getting a little crazy. So let's do, whoops. Let's do where they overlap. We have 3 pinks in column 7 and 3 oranges in row 4. So this cell cannot be pink or orange. It's guaranteed to be yellow. We should have something similar. We do. Row 6 has 3 yellows. Row 7, column 7 has 3 pinks. So this must be orange. And then we have column 3 in row 4. This cannot be pink, no orange, so that's yellow. Aha. And row 6, column 3, has 3 yellows and 3 pinks, so this can't be yellow or pink. It's orange. Well, now in row 4 and row 6, we have 3 yellows and 3 oranges guaranteed. So that means the rest are pink, guaranteed. Well, now we probably okay, so then now we have to do the ones where basically we do go row by row and column by column. Okay. Row 2 has 3 pinks, so the rest are yellow and orange. Row 3 has 3 yellows, so the rest are orange and pink. Row 5 has 3 pinks, so the rest are yellow and orange. And row 7 has 3 oranges, so the rest are yellow and pink. Row 8 has 3 pinks, so the rest are orange and yellow. Well, in column 2, we have 6 cells which either must be yellow or orange, which means that the rest of the cells in column 2 are pink. Now we have 3 pinks in box 1. That eliminates pink from the rest of the box, so this can't be pink, it's orange. Same with column 8. We have 6 cells which must be yellow or orange. That means these cannot be yellow or orange remaining in column 8. They're therefore 3 pinks. Therefore, we have a guaranteed pink here. 3 pinks in box 9, so this can't be pink, it's yellow. Okay. Remaining digits of column 3 have to be yellow or orange, because again, we have 3 pinks. And same with column 7. And same with column 5. Okay. That means box 1 has only yellow or orange left. Box 9 also has only yellow or orange left. We do know that these, so in column 2 and column 8, we have 2 each of yellow and orange. So these have to be opposite colors. So we'll mark those as medium and dark, right? But we don't have any distinction between this and these two. So this could be dark and medium. We don't know. Is that helpful? I'm not really certain it is. Well, these, we also have 2 yellow and orange in box 4, which eliminates yellow and orange, which means that this has to be the opposite set as this. So this must be medium. And we have the same situation in box 6. But we don't know what colors these are, right? We'll start by marking this blue and green, but this is not the normal blue as being lows and green as being mediums. That means this is one of each two. We also know that. Hmm. Can you ever have huh? If yellow orange were low, can that ever be the case and still add up to 18 and 17 here? 17, you would have to have 2 and 3 as the highest lows. That would be 5. So then these would add up to 12. I think that seems feasible. If you had this not be low, right? 2, 3, 2 doesn't work. Or I guess 3, 2, 3 could work with 9. But then this would have to be 3, 2, 3. That would be 9. Huh. How would that break down? We know these are opposites. Can you ever have orange, 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 and yellow, yellow, yellow here? Maybe? Hmm. Hmm. Okay. 18. That seems like potentially the largest restriction, but you could have 3 and 3 here. And then like 7 and well, hmm. So too high always adds up to 7 and 8 at minimum. So it's always 15. So yellow here cannot, well, this would be 7 and 7. But yellow cannot be high. So we know yellow can't be high. Yellow could be low. You could have 2 pinks here, in which case that's okay. It doesn't have to have 7 and 7. So 2 highs are always at minimum 7 and 7, so that's 14. So it cannot be here. This would have to be 7. Well, we know yellow can never be 2 highs, essentially. Actually, what does this add up to? That's interesting. So this is counted twice. So we have this, 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 and that. That's the sum of these two digits twice, and then everything else once. Huh. Um, so we have orange doubled, one of the orange doubled, and one of the yellow doubled. Um, hmm. What's interesting is maybe just take a look at these, right? You have two pinks and a yellow and an orange. And then you have two oranges and two yellows, adding up to these digits. So it's 33. The pinks see each other, so they must be at least 1, 2, at most 2, 3, or at least 4, 5, and at most 5, 6. Some combination of that. Um, we know yellow cannot be high. Huh. So we're guaranteed. Okay, in these sets, we have guaranteed two pinks, which have to be different, two yellows, which have to be different, and two oranges, which have to be different. So we're guaranteed 7 and 8 at minimum. 7 and 8 at minimum, 1 and 2 at minimum, and 4 and 5 at minimum. So that's 7 and 8, 15, 4 and 5, 9, so that's 24, and 1 and 2. Which is 3. So 7, okay, 1, 2, 4, 5, 7, 8, right, which subtracts out 3, 6, and 9. So that's 45 minus 18, which would be 27. And then these add up to 33. 33 minus 27 is 6. So we're, again, we have two oranges, which are different, two yellows, which are different, and two pinks that are different. That guarantees one of each set, two of each set, which must be distinct. So then we have 1, 2, 4, 5, and 7, 8 guaranteed. Which means that adds up to 1 through 9, which is 45, minus 3, 6, and 9, which is 18. And that's 27. And then we know these add up to 33 with the orange-yellow pair here. So that must be, then, the orange-yellow pair is 6 at most. Which means that orange and yellow can never be high. That means pink is always high. So pink is high. So we'll mark this as pink then with light. So that means these... Oops, I deleted. That's not good. Pink is red. There we go. And then we'll mark this now as pink and these as light. So red and or orange and yellow. Can you ever have 9 here? I think the answer is probably yes, right? Because you could still have 1 and 4. Yeah. So this has to be... Okay, so this is red. This is red. This cannot be red and red here, so therefore this must be orange. We have 3 oranges in row 3, which eliminates orange in the rest of the row, so that's not orange. This is not orange. This is 3 reds in box 3, which makes this yellow or orange. This is red here, red here. This is then... Can you have 2 mediums, a high, and a low adding up to 15 if that's the case? That would be, well, it could be 4 and 4 here. 4 and 4 is 8 plus 7 is 15 already. So the answer is no. So yellow has to be low, and orange must be medium. Okay, so this is low and low, and low and low. This is medium and high, adding up to 15. Can you ever have low, low, low here plus a high adding up to 16? I think the answer is probably yes, right? 3, 2, 3. Adds up to 8, yeah, or 2, 3, 2, right? These are 2 mediums, so this is 4 and 5 at minimum. That's 9 plus 7 at minimum, which means this is not green, this is blue. Which means this can't be blue, so this is green. This has to then be 4 and 5 as a pair, and this is 7, so in 1. That's the minimum here. Therefore, this is 6 here. This is blue. We have green here. We have 3 greens in column 6, so the remaining digits are blue and red. This is 2 lows. And it could be, it has to be 2 and 3 at least, or at most. That seems fine. This is 2 mediums here. Can you have 2 highs with it? 4 and 4, and then 7 and 7. No. So this cannot be high. This is low, which means we have 3 lows in column 4 now, which means the rest are medium or high. Okay. That means this must be low, 2 mediums, and a high. We have 7, 8, and 9 here. This can't be 7. This is 2 or 3 here. 2 or 3 here. It's 2 or 3 here. This is 4, 5, or 6 here. 4, 5, or 6. 4, 5, or 6. 1, 2, or 3 here. 8 or 9 here. And this is 1, 2, or 3. 4, 5, or 6 there. Can you ever have a 9 here? 9 plus 1 and 2 is 12, and that would force this to be non-blue. So no, you cannot have a 9 here. So this cannot be 6, because again, we have 2 high digits. This is 4 and 5 as a minimum. This is 1 and 2 as a minimum. And then 7 and 8. That adds up to 27. And then 1 is 28. So therefore, this can't be 6. Therefore, 6 in the central box must be here. What about these? Do we have something with these? Two highs. Mediums could be different. Sorry, lows could be different. Mediums could be different. Huh. Yeah, we don't have the same structure there. So can this ever be 1? 1 and 3? Yes, it could be. 4 and 9. That's fine. Can it be 2 and 3? Is another question. 2, 3 is 5. Plus 4 is 9. No 7 there. So no, cannot be 2 and 3. Therefore, this is a 1 guaranteed. We have 2 and 3 here. That means this has to be 1 here, because there's no other place for it in row 6. We have 2 or 3 here. Can this ever be 2 and 2? 2, 2, 4 is 8 plus 7. Yes, that could work. Can it be 3 here? I don't think so, right? If this is 3, this is 2 at minimum, plus 4 plus 7. 3, 2, 4 is 9 plus 7 is 16. So no, you cannot have a 3 there. This is 4, 5. 6 has to be one of these two digits here. I'm not sure which. We have 2 or 3 here. This is 4, 5. 4, 5. If this were 9, this would also have to be 9. And does that work? If you have 9 here, this has to be at minimum 4 and 4, but then this would be 2 at least. That's 10 plus 9, which is 19, which is too big. So 9 cannot be here, therefore 9 must be here, and this must be 8. So this adds up to 9. 16 minus 9 is 7, so 2, 5, 3, 4, both work. We could have 8 here if this is 4 and 4, and that's 2. That seems fine. This is 7 and 8, but the problem is this could be 2, 5, or 3, 4 here. Okay. This has to be 7 and 9 as a pair here. 7, 8, 9, 7, 8, 9. This is 7, 9 as a pair here, so therefore that eliminates 7, 9 in the rest of the column, so this is 8, which means this can't be 8, this can't be 7, it's 9, which makes that not 9 or 8, it's 7. That means this can't be 7 here. 7 and 9 eliminates 7 and 9 here, so that's 8. This can't be, oops. This cannot be 7 or 8, it's therefore 9. That leaves this as 7, this as 9. This has to be 8 to correspond. 8 cannot be here. It's 7 or 9. This has to be 7 remaining because of the 8 and 9 in the box. That makes this 9. This 8, this 9. So where is 8 in row 7? Can't be here because of 8 in the box. Can't be here because of 8 in the box. These are not high, so it must be here. So this is red and is 8. 9 eliminates 9 here, so this is 7 and 9. This is 8, 9 as a pair. We have 3 blues, 3 greens, and 3 blues in row. How did I miss that? Anyways, this can't be blue. This is red. I guess I didn't, complete these, essentially. So this must be 7 here. That leaves this as blue or green. Okay. What about ones? Do we have any information there? Not particularly. This is 2 or 3 also. 4, 5 here. This is 2, 3, or 4, 5 here. We have 4, 5, 6 here. 4, 5, 6. 1, 2, 3. Okay, so then we have to figure out these sums. Do we have anything special this way if we do that? Well, we do have these two as a pair and these two as a pair. Okay. Okay, so we have both reds twice. That's 7 and 8 plus 7 and 8, which is 15 plus 15. That's 30. So 30 plus 4 and 5 is 39. We have another at least 4 and 5 here. Okay, let's get a calculator. Oh, I don't want to do this all as one. So we have 7 plus 8 plus 7 plus 8. We have 4 plus 5. We have a guaranteed 4 plus 5 and a 4. We have 2 ones, so that's 2. We have at minimum 1, 2, and 2. That's 59. Minus 15, minus 16, minus 17. We have 7 degrees of freedom. So what's the maximum, actually, then we should probably look at? So 30 plus 9 plus 5 plus 6 plus 6 plus 1 twice, 2, plus 2 plus 3 plus 3 is 66. Minus 18, minus 17, minus 16, minus 15. And that's the maximum. So we know this has to be the maximum then. So then this must be 5. So we have to have 5 and 6 here. This is 6. This has to be maximum. So it's 3. This is 3. That's 2. 5 eliminates 5 here. So it's 4. Which makes that 5. Which makes this 4. Which makes that 5. So this adds up to 18. That's 10. Wait, that doesn't work. That's 3 and 7. How did I get that? That can't be right. Huh. So again, 7 plus 8 times 2 plus 2 for the 1s plus 9 for the 4 and 5 guaranteed here. And then we have at most 5 plus 6 plus 6 plus 2 plus 3 plus 3. And plus 41. So 66 minus 18 minus 17 minus 16 minus 15 is exactly right. So then how do I have this wrong? Oh, because I didn't double count these. That's why. Okay. Well, what happens if I double count them then? Okay. So that's, I guess, the question. Right, so we have to double count these. So then let's take the minimum again. So we have 30 plus 2 plus 9 plus 1 plus 4 plus 5 plus 2 double counted plus another 4 for the double counting plus 2. That seems to... and then plus another 4. Okay, that's close. 65. So we have 1 degree of freedom there, then. Is that right? Right. So again, take the minimum. Well, take the minimum of these two. So then we have 30 plus 9 plus 2 plus minimum, which is 9. Plus double counts, so 2 times 2 plus 4. Then another minimum, 4, another minimum, 1, another minimum, 2 is 65. So we have 1 degree of freedom. Therefore, the double countings have to be correct. And therefore, this is 2 and 5. This is 4. And those double countings are the minimum. So this is 5 here, no 2 here, it's 3. So this is 4 then, and this is 2, 6 as a pair. Which eliminates 2 and 5 in the rest of the column. This can't be 4, it's 5 here. This can't be 6. This is 5, which means this cannot be 6 here, because that would be 2 degrees of freedom that we lost, which we can only lose 1. So this is 4, this is 5, this is 6. So this is 2 and 4 here. That adds up to 6. 15 minus 6 is 9, so it's 1, 8, or 2, 7. 2 eliminates 2 here, so that's 3. This is 2. This has to be 2 or 3. This is 1 or 3 here. So we don't know anything about this. This can't be 3 because of 3 in the column. No 4 here because of 4 in the column. Okay, no 5 here. This is medium and it's 6. We have 1, 2, 3 there. Again, you could have 4, 5, 2, 7 there. Or 4, 4, 2, 8. Or 4, 4, 3, 7. All are possible. This is 1, 3, 4, or 6 here. We have 2, 3, 5, and 6 here. No 6 here because of 6 in the box. This is 4, 5, and 6, but no 4. We have 1 and 7 remaining in column 6. And this can't be 7 because of 7 in the row. So that's 1. This is 7, which makes this not high and this not low. So we have 3 highs in box 8. This can no longer be high. It's medium. We have 3 mediums in box 8. This can't be medium, so this is low. We have 3 lows in column 5. This can't be low, so this is medium, which means this can't be medium here because we have 3 mediums in the box. This is high and is 8. Probably could have figured this out anyways. 1 eliminates 1 here, so that's 2. That's the degree of freedom we lost. So this must be 2, this must be 4, and that must be 8. Yeah, we have 8 and 7, right? 2 plus 2 plus 4 is 8 plus 7 is 15. So 8 eliminates 8 here, so it's 9 and 8. 7 eliminates 7 here, so it's 9 and 7. This is 5, 6 as a pair. This cannot be 2. 2 eliminates 2 here, so this is 1. This has to be 5, 6 as a pair. This is 1, 3 as a pair. The only remaining medium here is a 5. So now we probably have to just do normal Sudoku. Okay. Remaining digits of column 7 are 2, 3, and... Actually, let's do column 3. Is 2, 4, and 6. 6 can't be here. So this is 2 or 4. And we have 2, 4, 6 here. Can't be 6 because of 6 in the row. So this must be 6 here. So it's not blue, it's medium. 2 here eliminates 2 here, so this is 3, which means this can't be 3. Where is 3 possible in column 2 now? It can only be here. So this is 3, this is 1. That eliminates 1 here. This has to be 3 because it's the last low digit. 4 eliminates 4 here, so it's 6, which makes this 5, which makes this 2. This can't be 2, it's 6, which makes that 2. So the mediums are blue. The dark is middle. 2 here eliminates 2 here. So this is 4, this is 2, which means this is not blue, and this is not green. We have 1 guaranteed here. 1 can't be here because of 1 in the row. So this is not low. This is not middle. This is the 1. And this is 5, which eliminates 5 here. So it's 6 and 5 there. Remaining digits of column 1 are 3 and 4. This 6 here eliminates 6 in the rest of the row. So this is 3, 4 as a pair, which eliminates 3 and 4 in the rest of the row. This can't be 3 or 4. It's 1, which makes this 3, which makes this not 3, so it's 4 and 3 there. This is not low. This is not medium. This is then the lights have to be medium, and the pink is low. So this is 4. This is 3. That's 4. We have 1 and 2 remaining in row 9, so these are both low. There's no green here. And this must be 2. This must be 1, which makes this a 5 here. So no blue here. It's green. We have 2 and 6 remaining in column 9. And this can't be 6 because of 6 in the row. So no green, no blue here. We have 3 greens in row 1, so this can't be green either. This can't be blue. This is 2. We have 2, and this is 3. This must be 4 and 6. And that's the solution. Yeah, pretty interesting puzzle. The entropy line, along with the sums, made for some interesting restrictions. It feels just a touch more difficult than easy, but I don't know if I would classify this as challenging either. And is it close enough to challenging where I would start classifying it as challenging? I don't know. A little bit tougher than easy, but I don't know how much more. I'll have to figure out how I want to rate the difficulty here. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.